Hello everyone. Today I'll be talking about our mini project that we had completed in third year second sem. The title of the project is Distributed Topic Modeling Paradigms and Societal Analysis for Health Forums through a Decentralized Platform. Let us now try to understand the project in detail. Medical forums play an essential role in the contemporary digital world by providing information, support, and a community for the world to navigate its health journeys. Health forums are majorly hosted on a centralized platform, and it brings forth several drawbacks like lack of privacy and security of sensitive personal health information, potential for bias and censorship to fulfill the vested interests of the central authority, and is much more costly to implement and maintain than a decentralized platform. Let us take a look at all the existing systems that are already available in the world. We have MediBlock, Doc.com, and Nebula. These medical forums on blockchains like MediBlock and Doc.com don't have topic modeling and sentiment analysis integrated into them. Our idea is to integrate both the above mentioned feature in the application that we develop to ensure a better experience for the user and the community. Hence, to improve the current state of medical forums, we proposed a medical forum with topic modeling hosted on a decentralized platform so that we can better understand the current topics of interest in the medical field and respond proactively. Using topic modeling to analyze the topics helps better understand the needs of the community and reduces response time. The usage of a decentralized network. The host of the forum also provides many advantages such as privacy, security, low cost, and less bias and censorship. The data provided is not used by a central authority with vested intentions. We also propose to implement sentiment analysis to improve user experience with better engagement and communication, and early detection of potential issues, and analyze patient feedback and opinions, allowing healthcare providers to improve their services and patient satisfaction. To better understand how this application works, let us take a look at one of the UML diagrams, that is the use case diagrams. Here we can see that there are many use cases that the application has and how the user can interact with the application hosted on a blockchain and how it in turn interacts with IPFS and machine learning. Here some of the use cases are signing in, signing up, log out, add post, view post, store data on IPFS, retrieve data from IPFS, comments, and machine learning. Here IPFS is interplanetary file storage that we are using to store the data of the tweets or the blogs that are posted on the medical forum. Now let us take a look at another UML diagram, that is the sequence diagram. The sequence diagram helps us visualize how the requests are sent to the blockchain by user to read or view a blog and how it is also sent to write a blog. Now this also shows us the information of how the machine learning algorithm takes data from the blockchain and which in turn requests the data from the IPFS. This data that is stored on IPFS is then sent to blockchain, which is then again routed to machine learning where the model is trained. By using this, we are able to develop a model that relies on the data from the application that is stored on IPFS and show out trends or results that are available in the medical forum. Let us now take a look at another one of the UML diagrams, that is the activity diagram. The activity diagram helps us visualize the activities that a user might go through when using the application. We initially start from authentication, from where we are able to log in or sign up. Once the authentication is passed, the profile is open. When the profile is open, the user has many things that he can do in the application. Some of them are creating a post, viewing a post, or adding a comment to a post that is already posted. Once the user is done with all the interactions in the application, he can choose to end his session. That can be done through using a logout. Now let us take a look at another one of these UML diagrams, that is called the data flow diagram. This diagram helps us visualize the flow of data and control in the application. Initially, the user logs in to the application where he creates an account. After creating an account, the user can make a blog post. Once the post validation is done, it goes through database, or which here is the IPFS. The IPFS is accessed using the smart contracts that is written in the backend. This smart contract is deployed on the blockchain. Now, the user can further view other posts posted by the user. This is also retrieved from the IPFS. Now, here we can also see topic modeling and sentiment analysis, which is the machine learning algorithms. These take data using the smart contracts from the IPFS, or we can use a web crawler to take data from the IPFS or the website and in the application. Now, let us take a look at the architecture diagram of the application. Here we see that we have a user interface which is connected to smart contracts. These smart contracts are deployed on the blockchain and have other attributes like transactions, ledger, and consensus that have the blockchain up and running. These smart contracts connect the database, that is IPFS. Now, these are also in turn connected with the machine learning. Machine learning has different stages that we have used to develop it. It has the input that is taken from the website. It has pre-processing. It has TDM, algorithms, LDA, NMF, which we have used. It has other ways of comparison like cosine similarity, etc. And then we arrive at the results. These results are then sent back to the user in the backend. Now, let us take a look at the implementation. Here is the application that we have developed. To use the application, we first connect the wallet and then navigate to profile. Here in the profile, we have to select a picture that we can use as our profile pic. I am choosing it from the file directory. Now, I am putting in a username and minting my profile. Here, we have to sign certain transactions using the MetaMask wallet. And once that is done and my profile is created, I can make posts. I am making a post here and sending it out. After signing the transaction fee using MetaMask, we can see that the post has been uploaded. Now, I will change the wallet address so I can show you how it is to use it from the perspective of another user. We have changed the account. Now, we are creating a new profile. We have to choose a picture that we can use for our profile, similarly like we used last time. Now, after signing the transaction, our profile will be ready. After this, we can go to home where we can make another post. Here, I am making a dummy post that we all can see. After this, we can see that the post has been uploaded. We can also see the option of being able to tip other users. This is the implementation of our website. Now, let us take a look at what the signing looks like. This is what pops up every time we make an event in the website. Every time we post a blog, this MetaMask notification pops out. This notification asks us to confirm a gas fee that we have to pay to go along with the process. Once we click confirm, this is done. It is to be noted that every time we post or tip someone in the website, we have to confirm this gas fees and we have to pay the amount. Now let us take a look at some of the graph that we have received by running the machine learning algorithm. The first graph that we can see is a heat map that we have received by running topic modeling algorithms on different sources that we have used for healthcare data that have been taken from Twitter. We have used the data from Twitter because the website does not have a lot of users and cannot have a good data set to run the machine learning algorithm. The first one is a heat map that shows us how the heat is distributed with different data sources and topics. The second is a user tweet count ratio or topic count ratio, which shows us how the topics are counted and the ratio with every other source. We also have a plot that shows us how the different topics are scattered. Let us now take a look at the output or the insights that we receive from running the sentiment analysis algorithm. We can see the polarity of the tweets in the first graph and the subjectivity of the tweets in the second graph. By using these insights that we receive from the algorithm of sentiment analysis, we can take certain proactive measures for the community. And last but not the least, our team and our project guide. We would like to thank Y. Subbarayadu, Assistant Professor, Department of IT GRAT. The group members are Deepak, Jain Potluri and Krishna. Thank you.